Hey everybody, welcome to Mr. Troy Does Math, a video series where I do math problems that I haven't seen before to show you how I think about them. Here we go. Oh, it had to be a big number. Okay, so this is probably a little bit more challenging than what you would see. I'm factoring with two variables. So I notice that 11 is prime. So, I guess I should write out the problem, shouldn't I? That gives me time to think. Haha. All right, so 11 is prime. So I assume I'm going to have an 11 and a 1. And these are going to be a squareds. And the reason they're going to be a squareds is because when you multiply them together, you get a to the fourth. And when you add them, you get a squared. If I would have done like a cubed and a, the adding wouldn't work out correctly. Okay, so kind of for that same reason, these are going to be d to the sixth. So 6 plus 6 is 12, right? Like d to the 6 times d to the 6 is d to the 12th. Now I need to figure out what to do with this 9. So there's a plus here and a minus here, so they both have to be negative. And if I put the 9 here, that would be like 99. So I'm going to put the 9 here and the 1 there. Let's see if that works. So 11a to the fourth minus 11a squared d to the sixth minus 9a squared d to the sixth plus 9d to the 12th. All right. I'm not going to type it into the problem because I trust me. Oh, okay. So another one. Same start to the problem, except here's the problem. Well, here's the problem. Haha, math teacher joke. It could either be 6u to the fourth times u to the fourth, or it could be 3u to the fourth times 2u to the fourth. So either one of those is possible because 6 is composite. So let's see what else I know. These have to be minuses for the same reason as the last problem. And the good news is that 5 only has one factor pair. So I'm going to have y to the sixths here, kind of for the same reason as the one before. And let's see, what else? Well, I guess I can just kind of start playing around with it. Okay, I think... Ooh, no. Ooh, okay. All right, I was wrong. How fun. Okay. Yeah, okay, so 5 and 6 make 11. So 5 and 6 make 11. Here's what I mean by that. Ooh, quiet you. If I put a 1 here and a 5 there, that makes negative 6u to the fourth y to the sixth, and this makes negative 5u to the fourth y to the sixth, so that is how it factors. For a second, I wanted to put the 5 here and the 1 here, but that wasn't going to work, so no, forget that. Okay, so let's see if we can find another one. Okay, I switched over a new problem type because variety is the spice of life. So here we go. This is more factoring, just practicing with a greatest common factor that's kind of weird. So let's pick one I haven't seen before, and... Okay, so I notice that each one has a 5x minus 2, but the other one is 5x minus 2 squared. So let me write this down. 3x minus 1. I haven't done a problem like this in quite a while, so it's kind of fun. Plus, I'm going to run out of space. This always happens. 4x minus 3 times 5x minus 2 squared. Let me see if I can move that over. There we go. Okay, so each one of those, and this is something you do in Algebra 2 that's really important to think about. Each one of those is multiplied by 5x minus 2. So let's pull out a 5x minus 2. And that would give me 3x minus 1 times 1 plus 4x minus 3. Now I'm pulling out one of these 5x minus 2's, but there's still a 5x minus 2. Now, I wonder if I'm missing something about how this problem works. Let's do it the longhand way and see what happens. I'll put that in parentheses so it's not weird. So 5x minus 2 times, and I'm going to FOIL this out. Feels like a mistake, but we'll see. So that's 20x squared minus 8x minus 15x, so minus 23x plus 3x from here. Plus 6 minus 1. I'm going to combine like terms. So 5x minus 2. I'm wondering if I'm missing something really silly here. Times 20x squared minus 20x plus 5. Okay, all of that's divisible by 5. Should I have known that already? So I can pull a 5 out all of the way out front. And 4x squared minus 4x plus 1. Does that factor? Yeah. So does that factor to 2x minus 1 times 2x minus 1? Yeah. Okay. So that's my final answer. I'm wondering if I'm missing something. Only one way to find out. Let's do another and see if there's a pattern or something. Okay, so totally same type of problem. Let's see if we can get any variety here. Okay, so this one's a little bit simpler. This one will be a little bit easier to follow. So I'm going to write it out. X minus 8 times 2x minus 1 plus 4x plus 3 times x minus 8. So x minus 8 factors out of that. That's pretty obvious. X minus 8. And I'm going to be left with 2x minus 1 plus 4x plus 3. That's going to give me x minus 8 times 6x minus 2. I guess I could use regular parentheses. Doesn't really matter. And I can factor 2 out of that. So 2 times x minus 8 times 3x minus 1. 3x minus 1. Interesting. All right, those are some fun problems, but no one wants to watch more than just that, so have fun. Thanks for watching Mr. Troy Does Math. All right, so I just plugged in the answer to see if there was anything else I didn't notice, and there wasn't, except I did this wrong. It should have been a +2, which makes that a +1. Oh well, sometimes in math you make mistakes, and what's important is that you go back and catch them in one way or the other. Right? Right. All right.